All right. I'd like to go on a journey with all of you through the land of iterables and iterators. But before I do that, I'd like to introduce myself. So that's my Twitter handle. That's my name. You won't see those again, but you can look them up in the program. My name is Trey. I help Python and Django teams onboard new teammates, and I help turn front-end developers into full-stack Django developers. I also host a free live webcast every week, usually Saturday mornings, I guess Saturday noon Eastern time. And I co-organize my local meetup in San Diego. I've helped co-organize 4 Django Girls workshops in the Southern California area, and I am one of the 13 directors on the Python Software Foundation board currently. So that's a little bit about me. Let's talk about looping. Every interesting journey starts with a problem. We're going to look at some confusing looping problems in Python here, just a few to pique our curiosity and motivate us to learn. So numbers here is a list. Squares is a generator. If you haven't seen generators before, that's all right. You'll just have to believe me, that is a generator. This generator will give us the squares of each of the numbers in that list. Generators are lazy. We can't do much with generator, or we can't do much with this squares thing except for loop over it. We can pass it to the tuple constructor here. If we do so, what are we going to get? Tuple. We get a tuple out of this if we pass it to the tuple constructor. If we pass it to the sum function, we will get the sum of this generator. Or we think we get the sum, we get 0. The sum of this generator is 0. So we're going to talk about what is going on here, why this is happening. Another example, if we ask whether 9 is in this squares generator, we will get true. It is true that 9 is in this generator. If we ask the same question again of Python, it tells us false. 9 is not in this generator. We're going to talk about what's going on here too. This dictionary has 2 key value pairs. If we try to unpack this dictionary into 2 variables, you might think that we would get an error. It doesn't make sense to do this. We don't get an error. Python does allow us to unpack this dictionary. So that is a little bit weird that we can unpack a dictionary. At this point, you might be expecting that X and Y are maybe tuples of key value pairs, maybe apples 2 and oranges 1. You'd be wrong, unfortunately. It is not a tuple that we get back with X. It is a key. We get keys when we unpack a dictionary. We'll explain what's going on here as well. Okay, so some quick review. Who is using Python 3 primarily? Okay, that was a lot of you. I am proud of you all. Everyone else who didn't have your hands raised, something. Look at all those hands that were raised. You should be using Python 3. So there's only, I think, one slide that is Python 3 specific. Good luck finding it. It doesn't really matter. This is a mostly Python 2 and Python 3 oriented talk. The same applies for both. We're going to review real quickly loops, iterables, and sequences. This is a for loop. This is not Python. This is JavaScript. This is a traditional C-style for loop. We set I to 0. We check whether I is less than the length of this array, which is the same as a list in Python. We increment by 1 each time we loop. And we print out those numbers as we're looping. Then we increment after each loop. Once that condition is no longer true, we're going to stop looping. This is a for loop, prints out each item in this array. Python does not have for loops. At least we don't have traditional C-style for loops. Python doesn't have for loops. We do have for in loops. Our for in loop is the same as what many programming languages call a for each loop. We tend to call our for in loops just for loops, though, because they're the closest thing we have to a traditional C-style for loop. They are different, though. In this for loop, we're looping over each item in our list and printing those items out. We don't have any indexes here. There's no I equals 0, no plus plus, no plus equals 1. Python does all that work for us under the hood. So Python doesn't have traditional C-style for loops. We do have something we call a for loop. It works differently. If you can loop over something with a for loop in Python, it is an iterable. And if something is an iterable, you can loop over it with a for loop. That is the definition of that word, iterable. So if you're not sure what iterable means, it means something you are able to iterate over, an iterable. Iterables can be looped over. Anything that can be looped over is an iterable. Okay, so we've seen for loops, we've seen iterables. Sequences. These are a very common type of iterable in Python. Lists are sequences, tuples are sequences, strings are sequences. Sequences are iterables, which can be indexed starting from 0 to 1 less than the length of the iterable. Lists, tuples, and strings, and all other types of sequences can be indexed in this way. They have some more features. We're not going to talk about those. Sequences are their own type, special type of iterable. Lots of things in Python are iterables, but many things in Python are not sequences. Sets are iterables, dictionaries are iterables, files are iterables, and generators that we've already seen are iterables. There are even infinitely long iterables. Count in the itertools module is an infinitely long iterable. None of these iterables here are sequences. So you can't assume that something is a sequence when you see it and someone says it's an iterable. So Python doesn't have traditional for loops. We do have something we call a for loop. Anything that can be looped over with a for loop is an iterable. Sequences are just one type of iterable in Python, but there are many other types of iterables. Okay, so we're done with review at this point. If any of that was new, this is going to be a little bit more of a struggle for you. Hopefully much of that was review at least. Let's talk about how for loops work in Python. So specifically, I would like to implement, or rather, I would like to loop over an iterable without using a for loop. You can loop over an array using a while loop or a for loop in JavaScript. How could we loop over an iterable, any iterable, without using a for loop? So you might think that under the hood, Python's for loops use indexes to loop. This works for lists. We have a list here. We're setting I is equal to 0, I is less than numbers, I plus equals 1. That works fine for lists. This only works for sequences, though. You can't loop with indexes if you have a non-sequence. For example, sets. This is a set here because we're using those curly braces. This is not an index, or this is not a sequence. We cannot index it. We get an error if we try to loop this way. So if we're looping manually, we can't rely on indexes because not all iterables are sequences. Plus, this wouldn't work for infinitely long iterables here if we were to try to index. It doesn't make sense for them to have an index. We could try to convert this to a list. Again, that's not going to work for infinitely long iterables. If you try to convert an infinitely long thing to a list, your RAM's going to get unhappy. Iterators are the secret to looping in Python. We've got to talk about a new thing here. Every iterable in Python can give you an iterator, and you can use that iterator to iterate over something manually. Okay, so we have 3 iterables here, a list, a tuple, and a string. Each of these iterables, we can ask for an iterator using Python's built-in iter function. Passing an iterable to the iter function will always give us back an iterator, no matter what type of iterable that we're working with. Lists, strings, and tuples are all iterables, and every iterable will provide you with an iterable will provide you with an iterator if you ask it to do so. That's probably not the last time I'm going to mix up those two words. Iterable and iterator are very similar. It's confusing. Once we have an iterator, there is only one thing that we can do with it. Get the next item from it. We can use Python's built-in next function to get the next item from any iterator. And if you ask an iterator for its next item and there are no more items left, you'll get a stop iteration exception. So iterables, you are able to iterate over. Iterators are the thing that actually does the work under the hood. You can think of iterators as kind of like a tally counter. They're like a one-directional tally counter, though. They only go in one direction, and they have no reset button. Once you're done with that tally counter, you have to throw it away once you're done with it. So iterators are like a one-directional tally counter without a reset button. Iterators are also like Hello Kitty Pez dispensers. They're like Hello Kitty Pez dispensers, except that they cannot be reloaded once you're done with them. Once you take a Pez out, it is gone. And once the dispenser is empty, it's useless. You have to discard it. There's no recycling of these things. Iterators are like Hello Kitty Pez dispensers that cannot be reloaded and cannot be recycled. Okay, so now that we know about iterators, we know that they are Hello Kitty Pez dispensers. Let's take this for loop and attempt to turn this into a while loop the right way without using indexes. So we know we can't use indexes, so we will end up using iter and next to loop over this iterable here. So this code here is equivalent to this code here. In order to manually loop over an iterable, we need to get an iterator from it using the iter function. Once we have an iterator, we can loop repeatedly. We've got a while not done looping there. That's some Boolean we've set. We get the next item from that iterator each time that we loop here. Once we have that next item, we can execute whatever the body of our for loop is actually supposed to do. In this case, it's action to do, whatever that means. And if we get a stop iteration exception while we're getting that next item, we know that it is time to stop looping at this point. So we have just reinvented a for loop by using a while loop and what we've learned about iterators, using iter and next. This is how for loops work under the hood in Python. They grab an iterator, they call next over and over until they get a stop iteration exception. The code that we just wrote pretty much defines the way that looping works under the hood in Python. This set of rules of how to use iter and next to loop over things has a very fancy name, the Iterator Protocol. This is the thing that powers all iteration in Python. For loops rely on the Iterator Protocol. Iterable unpacking uses the Iterator Protocol. Star expressions also use the Iterator Protocol. Anywhere you see any type of iteration happening, there's probably the Iterator Protocol being invoked under the hood. So for example, when you convert something to a set, there's some looping going on there. The Iterator Protocol powers all forms of iteration in Python. Okay, so you might be thinking, iterators seem cool, but they also just seem like an implementation detail. Who in this room is a Python core developer? No one raised their hands. No one in this room is a Python core developer. Why do we care about iterators? They seem like an implementation detail. So I have some news for you. You have seen iterators before, even if you didn't know it. I showed you generators at the beginning of this talk. This is a generator, squares. This generator object is an iterator, which means that we can pass it to the next function to get the next item from it. If you've used a generator before, you know there's something else you can do with generators. There's something else you can do with generators besides passing them to the next function. You can loop over a generator. A generator is an iterable. An iterable is anything that can be looped over, which means a generator must be an iterable because we can loop over it. So I just told you generators are iterators, but you know that generators are iterables. So which is it? What is going on here? So I haven't quite been telling you the truth yet. There's something important that I neglected to mention about the Iterator Protocol, how it works in Python. Iterators are also iterables. This is true of every iterator. So what this means is that we can get an iterator from an iterator using the built-in iter function in Python, just like we can with any other iterable. So we can call iter on an iterator to ask it for an iterator. When we do that, it will give us itself back. Iterators are iterables, and their iterator is themselves. Iterators are their own iterators. Who is confused at this point? Yeah, I expected most of you actually to be confused at this point. This is a little confusing. This is the most mind-blowing part of the Iterator Protocol, which is why I neglected to mention it before. So this fact that iterators are also iterables and that they are their own iterator, this is the last part of the Iterator Protocol. If you ask an iterable for an iterator and it gives you itself back, it must be an iterator. So iterators will always give you themselves back when you ask them for an iterator. And if something gives you itself back when you ask it for an iterator, or it is also an iterator itself. So iterators are iterables, but they have no idea how many items they contain. They are very dumb iterables. They don't have a length. They can't be indexed. The only thing that you can do with an iterator is ask it for its next item, or, as we know now, loop over it, because they are also iterables. And if we loop over an iterator a second time, we'll get nothing back. Iterators are lazy iterables. They can only be looped over once, and then they're done. So some quick review. Iterables are not necessarily iterators. Iterators are always iterables. Generators, I mentioned that they are iterators, which means they're also iterables. They are both iterables and iterators. Lists are not iterators. They don't have that property of being lazy. They are iterables, though. In fact, they're sequences as well. Don't worry about that. So iterables are not always iterators. Iterators are always iterables. Okay, so this is a little bit confusing. Do you really need to know any of this? I mean, I mentioned that we're not Python core developers. It's nice to know how generators work under the hood, but is that the whole point here? So iterators allow you to be lazy, and they allow your code to be lazy. Iterators allow us to both work with and create lazy iterables that don't do any work at all until we ask them for their next item or until we start looping over them. Because they are lazy, you can actually make infinitely long iterables. You can also make iterables that delay any type of execution until you start looping over them. So you can make iterators, or lazy iterables, if you like to think of them that way, that are conservative with system resources. They can save memory, sometimes they can even save time. Okay, so you have already seen lots of iterators in Python. As I've mentioned before, generators are iterators. The enumerate object is also an iterator in Python. Zip objects are also iterators. This is Python 3 specific here for sure. And a number of other objects in Python are iterators. For example, reversed and file objects. There are lots of iterators built into both the standard library, Python itself, and a lot of third-party libraries that you use. These iterators all act like lazy iterables. So it's useful to know about iterators because you use them quite a bit, but you can also create your own lazy iterables. This is a little bit of a strange way to do it, but I want to show you this. This is how it's done under the hood. This class here makes an iterator that accepts an iterable of numbers and squares each of those numbers as we loop over this square all iterator. If this iterator was passed an infinite iterable, it would lazily square each item as we looped over it. Our memory would not fill up just because we got an infinitely long iterable there. So this works here, but this is not how we normally make iterators. We normally make iterators by making generators. This is a generator function here. That yield statement probably seems magical. It is a little magical, but it is very powerful. Yield allows us to put our generator on pause between next calls. So you now know how generators work. Between next calls, that yield puts our function on pause. This generator function, we could implement this in yet another way using a generator expression. This is a shorthand for making a generator, the same way list comprehensions are a shorthand for making lists. This does the same thing as a generator function, but it uses a syntax that looks more like a list comprehension here. So if you need to make a lazy iterable in Python, think of iterators and consider making a generator function or a generator expression or using a library that will allow you to get an iterator out of something. Okay, once you've embraced the idea of these lazy iterables and making your own lazy iterables, you will find that there are actually lots of possibilities for discovering or creating your own helper functions that assist you in looping over all sorts of iterables and processing data oftentimes in many ways. So this is a for loop that sums up all billable hours in a Django query set. You don't need to know anything about Django here. This is essentially just a for loop. This is the same thing using a generator expression. So we have a generator expression here, and we're lazily evaluating this code. That billable times thing, no work has been done at that point. Notice we're able to use the sum function because we have a lazy iterable. We've fundamentally changed the way we structure our code here. We were able to do this because we used an iterator or a generator here. So iterators allow you to fundamentally restructure your code and change the way that you write your code and think about your code. This code prints out the first 10 lines of a log file. This code does the same thing. Notice that that first 10 lines variable there in that second block, that is an iterator. That variable name didn't exist at all before. We've named something that didn't have a name before. Naming things is important. If something is important, it deserves a name. We've gotten rid of a break statement as well. We've really restructured our code here. So iterators and generators in general, or generators and iterators, they are not always the answer to your problems, but these lazy iterables allow you to change the way that you structure your code. This code makes a list of differences between consecutive values in a sequence. Notice that this code has an extra variable that we need to assign to each time that we loop that previous variable. This is the same code, but we're using a generator function. Now, I made this generator function up. My fancy utils module doesn't actually exist. If it did, and it had a with previous function in it, we could imagine for previous comma current in with previous, this actually would allow us to grab the previous value as well as the current one as we loop. lazily. If you want to see how this generator function can actually be executed, I'm going to show this code real quick. I don't think I have time to explain it. So in case you're curious, this is what that mysterious generator function could look like, or a plausible version of it. Notice that we're using iter and we're using next here. We are relying on the Iterator protocol in a pretty fundamental way in implementing this generator function. So I'm not going to step through this. You can look at my slides afterwards and try to wrap your head around that. Okay, so at this point, we are ready to jump back to those odd examples that we saw earlier and try to figure out what was going on. Here we have a generator object squares. If we pass this generator to the tuple constructor, we'll get a tuple of its items back. If we then try to compute the sum of the numbers in this generator, we'll get 0, because this generator is empty at this point. Generators are iterators. And iterators are like Hello Kitty Pez dispensers that cannot be reloaded. Once we run out of Pez, the dispenser is forever empty. So this tuple is empty forever at this point. If we ask whether 9 is in this generator, we will get true. If we ask the same question again, we get false. The reason this happens is that Python has to loop over this generator in order to discover whether 9 is in it. There's no other way for it to tell whether 9 is in it without partially consuming it. So 9 is in this generator. At this point, if we then convert it to a list, we get those last 2 items in it are 25 and 49 because we've consumed 1, 4, and 9 up to this point. So I want you to remember that iterators are like Hello Kitty Pez dispensers, or they're like one-directional tally counters without a reset button. There is no way to know whether something is in them without partially consuming them. So we have to start looping over these things to find out whether there's anything in them at all. At the end. When you loop over dictionaries, you get keys. Looping relies on the Iterator Protocol. Iterable unpacking also relies on the Iterator Protocol. All forms of looping in Python rely on the same thing, the Iterator Protocol, which means we get keys as well. Now that you know this, now that you know that all these forms of looping do the same thing, this should be obvious behavior. If you've seen the looping example, you understand the iterable unpacking example. Iterators are the most rudimentary form of iterables. When working with iterables, I want you to try to assume that you're working with iterators, because you very well might be. Iterables cannot necessarily be indexed. Sequences are one type of iterable, but they're not the only type of iterable. You cannot assume that your iterables can be indexed. When someone says the word iterable, all that they mean is something that we can iterate over, and that is it. Try not to assume that iterables have any features beyond iteration. And if you need to make your own lazy iterables, if you want to make memory efficient or lazily evaluated iterables, think of iterators and consider making a generator function or a generator expression for that block of code. Also remember that if the operation that you're doing may be using looping under the hood, you are relying on the Iterator Protocol. And understanding the Iterator Protocol will give you more insight into what's actually going on. So that is all I've got for you. Here's some links that you can't click here because they're links, but you could look up my slides and or look up the names of those talks. These are some talks and resources I recommend. I don't usually take questions after my talk, but I think I'd be fine with a few questions if we have time. Otherwise, find me in the hallway afterwards. I'd love to chat with you. Thank you. Yep.
So I noticed that you didn't mention comprehensions, must have been intentional.
Yeah, I didn't mention comprehensions because I had 25 minutes. Comprehensions, comprehensions are to generator expressions as lists are to generators. That's the way I think of it, but we can talk about that afterward. Yeah.
I hear that things have totally changed with respect to how iterators are used in Python 3. Can you explain?
In the hallway, we should talk about that. So the question was, can I explain the way that things have changed in Python 3 in respect to iterators? Yeah, let's move to the hallway. If folks have more questions, feel free to find me in the hall. Let's chat. I want to let the next speaker set up.